All right, geometry. Today we're going to learn about transformations. Transformation, think, just means change, right? So we're going to learn about a few different kinds of changes that we can apply to things like polygons. We're going to create those things. They're called translations, rotations, and reflections. We will go more over those three particular types of changes or transformations. All right, first of all, these are called rigid transformations. Right? Rigid transformations retain the same shape of the original image. Right? So the original looks like this, and the image of the original looks just like that. It hasn't expanded, it hasn't shrunk, none of the sides have changed length or anything like that. It looks the same, it's just in a different spot or it's in a different position. So it's a rigid transformation. It retains the same exact size and shape. Right? So these are three types of transformations. I have a translation. Translation is just, we could say, a slide. We just take it from one point and move it to another point. So I'm just taking something and think about your textbook is on one side of your desk, you slide it across to the other side of your desk. That's a translation. If that's a translation, then a rotation must be a turn, right? So if you take that book, kind of put your hand in the middle and turn it around in that way. So the middle of the book is your point of rotation, and you turn it around that point of rotation. That's a rotation. So in this particular case, there's my point of rotation, and I'm turning this image around that point. So now it's in a different position. So notice this light blue piece is now over here. So it's different from a translation. I didn't just slide it over. If I just slid it over, that light blue piece would be right here, right? I turned it so that it's in a different position. And finally, I have a reflection. So we could call, and this isn't a great word for a reflection for various reasons, but for now we're going to call it a flip. So I take my original image and I flip it across this line of reflection. So there's a particular line where I take that image and I flip it across. Think of it as a mirror, right? A mirror image is a reflection. We call it a reflection. When I look at myself in the mirror, I see a reflection. So here I am, right? And my reflection is over here. It's like I've been flipped across that line. All right, so another thing that you're going to be seeing is this translation vector. Okay, a translation vector is just a line across which an original image is slid. You slide it across a particular line. That's called a translation vector. Let's not worry about this patty paper. We may work with that in class. But just think of the vector again as a line which you are sliding something across. All right. So on a coordinate grid, it's going to look like this. So I took this original A, B, C, and I slid it across the coordinate plane. There's a translation on the coordinate plane. So I'm going to say that I slid it up 1, 2, 3, and over 1, 2, 3, 4, 5 to end up at my new point. So I slid it up 3 and over 5. Okay, so that's a slide on or a translation on a coordinate plane. And I would do that with every single image. I got to do everything the same way. So if now I look at B, I still want to go up 3, or point B, I still want to go up 3 and over 5. So let's make sure that's the case. Up 1, 2, 3, and over 1, 2, 3, 4, 5. And so again, up 3 and over 5 to get my new image. This, by the way, we would say B prime. So that little dash right there means is said B prime, and what that means is it's the new image. We have the original and the new image, and the new image is going to be called prime. All right, so same thing over here. I take one point. Let's take E, and we go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So up 4 and right 5. Right. Oh, you know what? I did that the wrong way, didn't I? I started with my new image and went to my original. So instead, I'm going to go back 1, 2. I'm going to go down first because that's what we've been doing. 1, 2, 3, 4. So down 4 and over 1, 2, 3, 4, 5 to the left, 5 to get E prime is what it's called. You don't have to write out prime. When you say this, you say it E prime for the image after the original. All right, rotations to me don't come easy. Maybe they come easily for some of you, and that's great. If you're a really spatial person, these might be good for you. So again, a rotation is a turn. So all the points in the original figure rotate or turn the identical number of degrees around a center point. So I know I covered some of that up, so I'll erase that. They turn an identical number of degrees around a fixed center point. You can define a rotation by its center point and the degrees, right? So here's my center of rotation. Right, so that's one way to define a rotation. I'm going to start with, there's my center. My center of rotation is here, and I am turning it a certain number of degrees around that center. All right, so defined by center of rotation and degrees. This will be a little delayed. All right, so let's look at a couple of images down here. So if this is my center of rotation, and I draw a line from that center of rotation up to a particular point in that image. And then over here in step 2, so your step 1, I have a center of rotation. I'm going to draw this line from that center of rotation to a particular point in that image. Step 2, I'm going to turn that image a particular number of degrees, or angle of rotation. So right there is my angle of rotation. So I'm just going to think of it as taking that first ray right here and moving it up to that second ray. And my image comes along, or my image goes along with it to get my new image. Sometimes the original is called the pre-image. So that would be the same as the original. And then the second one is called the image. So after you transform that pre-image, that's going to be called your image. Or you could think of it as your before and after. Pre-image is your before, image is your after. All right, let's take a look at a reflection. So I know that can be hard to read, but that's just highlights what a reflection is. You got to kind of read that backwards. That paragraph has been flipped around or reflected. So the important thing about a reflection is I have, let's look here. The line where the mirror is placed is called the line of reflection. I'll say that again because I know it's hard to read. The line where the mirror is placed is called the line of reflection. So think about standing in front of a mirror. That mirror is the line of reflection. You are the original, your reflection is the image, or you are the pre-image and your reflection is the image. So if the mirror is right here, and this is the original, this is you, when you're looking in the mirror, this is what you're going to see across that line of reflection, right? You can notice here that if we look at the second one, it looks like this half has just been flipped over the line to create the second half. In other words, you can see the symmetry here, right? So you can see that that line of reflection is also a line of symmetry. If you fold that in half, you're going to get two equal pieces. All right. So let's just take one example here. On a coordinate grid, let's see how this looks. Let's work particularly with A and B. C I'm not going to worry about so much at the moment. We're going to reflect this triangle across the y-axis. So here's our y-axis. So our y-axis is our mirror. We're going to reflect this triangle across the mirror, right? So when I reflect, there are a couple things to remember. Point A right here is a certain distance from the y-axis, right? That's 2 units from the y-axis. That means when I reflect it, it should still be 2 units from the y-axis. So that means directly across from there, I'm going to have my A prime. Okay, still 2 units from the y-axis. All right, so let's take a look at what that means for b. So b here is, again, looks like 2 units from the y-axis. So b is still going to be, or b prime is still going to be 2 units from my y-axis. I'm going to do that in a different color so it's easier to see. So here I have my a prime. So for my image, I have a prime and b prime. All right, now let's take a look at c. So how far is c from the y-axis? So it looks like it's 1, 2, 3 units from the y-axis, which means on the other side it's going to be 1, 2, 3 units from the y-axis. So there's my c prime. I go ahead and connect those points. I'm going to do this the best I can. So notice how that new triangle looks. A prime, B prime, C prime. So can you see how that is a mirror image across that that mirror of the y-axis? And it's just been flipped across the y-axis. Each and every point is the same distance from the y-axis it was before. It's just on the other side of it. So A was in the upper, it's the second quadrant. So A was in the second quadrant. When I flip it across that vertical y-axis, it ends up in the first quadrant, and so on, right? Again, same, I'm going to write this over here, same distance for each point, same distance from the line of reflection. So I'm saying this a little bit late, but make sure to have a coordinate grid in front of you so you can follow along with this, because you will be having to do this in class. All right, so now so it's a reflection, right? Okay, now, so I'm going to get rid of that. Got to rename that A, B, C. So I'm going to deal with part B. Translate the triangle 2 units to the right and 3 units down. So now for my image, I want to follow those directions. It's kind of following the direction of a vector. If I were to have a vector on here, it would follow that path, 2 units to the right and 3 units down. So I'm going to take each and every point and follow those directions. Simply 2 units to the right, 1, 2, and 3 units down, 1, 2, 3. And there is my A prime. All right, so we have A prime, vertex right here. I'm going to do the same thing with B. I'm going to go 2 units to the right and 3 units down. So there's B, and I go 1, 2 to the right, and there's B to start. So 1, 2 to the right, and 1, 2, 3 down. So now there's B prime. All right, and now I have C to deal with. So again, 2 units to the right. So I'm starting here, 1, 2, and 1, 2, 3 down is going to be C prime. So I'm going to connect those points the best I can. And so we can see that all we've done is taken that image and kind of slid it diagonally. It hasn't been turned or flipped. It's just been slid diagonally down to the right. All right, so there's our translation. So we're going to slide up or down, and then left or right. Oops, left or right. All right. So the clockwise, rotation 90 degrees clockwise around the origin. So I'm going to erase this again. And we got A, B, and C. Right here are vertices. I'm going to rotate it 90 degrees around the origin. So here's the origin of our coordinate plane. I'm going to go 90 degrees around that origin. So that means when I turn each point, remember if I draw a line from, so I'm going to demonstrate this here with, I'm actually going to do point C. So if I draw a line from my center of rotation to point C, my new point should have a 90 degree angle to go along with it. All right, so point C, if I do that 90 degrees, I'm actually going to write the coordinate up here. So you know that point C, if we look back to the beginning, is 3, 1, right? So notice what happens when I rotate that. So now I'm going to go let's see, I end up right. C prime, so there's C, 3 comma 1, and C prime ends up being negative 2, 1. Okay, so take a look at that angle. Now this doesn't look great as an angle, but that angle, if I draw a line from the center to that new point, I see that that is, I'm going to double check that coordinate. It looks like I might have that wrong. All right, so I'm going to double check that. I was wrong. I was using the wrong original point, so I altered that. So my original C was 3, 1. When I turn that around the origin, counter, this was clockwise, 90 degrees. I'm going to end up at, oh, still going the wrong way. Let's try this again. I should end up, see, I told you, rotations are hard for me. So if they're hard for you, don't worry, you might be better at them than I am. So my C prime is actually going to be down here. So here's my point of rotation. All right, let's try this again. This isn't writing. Oh, great, now we're not writing. So, all right, there we go. So here's my original, right? Clockwise is going to go this direction. So when I turn that 90 degrees, you can see that that's your right angle, and I end up at negative 1, negative 3. Negative 1, negative 3. So see, when you're turning it 90 degrees, you draw your line from the original point, from the center of rotation to your original point, and then your new one from the center of rotation to your new point. You're going to see that that's 90 degrees. And then notice, last thing here, notice my ordered pairs. You can see that relationship, right? Looks like they've been flipped around, and it looks like they both become negative. For this particular rotation, that's going to be the pattern you're going to see. So I'm not going to finish that one off, but if you did, you would see a similar pattern in your other points.